This is the foldable for section 7.2. I want you to have it facing up this way, and you're going to fold it in towards the center. I'm going to write it over here. This is for 7.2. What we're looking at in section 7.2 is similar figures. And the reason that we did proportions on the last one was because we need those to see whether two figures are similar. These are not equal, they're not congruent, they're similar. So they look pretty much the same, only that one is bigger than the other. Alright, so let's take a look as to determine the angles and the sides. Usually when you have something like this, you're told that they are similar, and you just have to tell me which sides correspond with one another. So congruent angles, I want you to look at the marking. We have this one single mark. So that means angle A is congruent to the single marking over here with this angle G. The other one has the two markings, so we have angle C is congruent to angle F. The third angle does not have markings, so we tend to want to say that they're not congruent, but there is a theorem that says that if you have two that are congruent, the third one will have to be equal. So I'm just giving you an example. So if this was 30, let's make it 60, and this was 30, and I already know that these are congruent, 60 and 30. The angle that's left has to be 90. It's not. It doesn't look like it's 90. It's just an example. So this one would have to be 90 so it could equal 180. That means this one would also have to be 90 so that it equals 180. So this is just my example of if you know that two are equal, the third one has to be equal. And that's a theorem. We don't have to know the name for the theorem for this section, but I'm just letting you know because now we can say that angle B is congruent to angle H. And then the sides are proportional. So we know that the angles are congruent, but the sides are proportional. So remember what I told you, proportional is just a fraction of comparison. Since I know that AB, it has these two angles between them, and they're 9. So I also know that GF will correspond with that side. So this is a little difficult because we have to know which sides correspond. So I'm going to say it again. A corresponds with G. And if we move along that side to that line, and we go to the two markings of the angles, we know that C corresponds with F. And we know that by the angles, but we also need to know that by the sides. That means AC is the one that's going to be compared to GF. We know that the order of the letters don't matter when we're talking about segments because they would indicate the same segment. But in this case, you actually want to write them in the correct order because it just makes it easier for you to follow along. So for example, if we have CB, and we have proportional sides, proportional, remember, was ratios that are equal. That's why I'm writing an equal sign. If I went from C to B, that's the one with double markings to the one without marking. So that would be FH. So CB corresponds with FH. So I'm gonna say it again just to make sure that everybody's okay. We have C that corresponds with F, and if you go along that side to the angles that do not have markings, B and H, that's how I get the sides that are proportional, or the ratio, the constant ratio. I'm always writing this one first because that's the one I see first. Sometimes in your homework assignment, it will tell you which one they want you to write first. Make sure that the one that is stated first is the one that you write first. All right, so this one was first, so I'm going to write BC is being compared to FH. And then the last side we have is BA. That goes with no marking along the side. So we're actually talking about that side to the angle with one marking. So if I go over here, no marking towards the side with one marking. So that would be HG. To find the ratio, we're just making the scale factor is what it's asking for. Anytime that it's asking for the scale factor, is asking for the numbers that represents those proportions. I see that AB or BA has a 7.5. And since I'm going to compare it to HG, that's a 5. And this is why on the previous homework assignment, I kept asking you to always reduce your fraction. We have 7.5 divided by 5 gives you a 1.5. We don't need that decimal. We need a fraction. Again, that's why we were doing it on the last homework assignment. We have 3/2. So this scale factor is 3/2. Let's take a look inside. So usually when they tell us to write the corresponding sides, they're telling that these two figures are similar. They are similar. How that is written in instructions is that they usually go in alphabetical order. A, B, C, D. So they're telling you this one is similar. And this is the notation for similar. The quadrilateral, and since we started with X, let me make sure with my notes that I did previously. If we start with A, we're going to start with Y. Another way that we would want to start that way is because it's the only one with a 105. Otherwise, what we try to do is write them alphabetically. But this one won't work out this way. And I'll explain here in a little bit. So Y corresponds with a 105. We don't know what this one is, but we want to the 85, so that has to be X. And then we wrote C, which is 100, and that corresponds with W. And the one without the marking was D, and that corresponds with Z. So that's the reason that this one doesn't really go alphabetical, because the letters don't correspond that way. The angle measures don't correspond. Well, let me say it again this way. We know that the angle A was congruent to the angle Y. How do we know? Well, they're both equal to 105. And we know that angle B is congruent to angle X, 85. We know that angle C is equal to 100. Oops. So we want to know that is congruent. So look at the symbols for congruent. That means equal to and then similar. It just has one wavy line. To the angle C was 100, W, angle W. And then the last one without the marking, angle D, is congruent to angle Z. Well, we know they have to be equal because when you have a quadrilateral, they have to equal 360. So 360 minus 105 minus 85 minus 100, you're going to get 70. Sort of like a triangle, you know what the sum has to be, so whatever is left is going to end up being the same. We have 360, because it's a quadrilateral, minus 105, minus 85, minus 100. What are you left with? 70. And that's how I knew that that angle that didn't have a measurement had to be equal. So all the sides, all of them have to be congruent. All the angles have to be congruent. The sides, though, on the other hand, are not going to be equal. They're going to be proportional. They're going to have the ratios of the sides. So if I'm comparing A to B, and like I mentioned, the one that they give you first is the one that you're going to write first. So that's why I'm writing AB first. And then the denominator will be the one that they give you second. Luckily, the order of the letters, once you have them written down like this, helps you of which sides correspond. So this would be YX. And that is equal to, because ratios are numbers. And then look at BC. So that's this one right here. And that corresponds with XW. So I like writing it this way. It helps me with the proportions. And then we have CD. And it corresponds with WZ. And then the last one that most students forget is DA. So that would be ZY. Remember, it has 4 sides, so 4 sides have to be proportional. The denominator in this one was a ZY. So how do you get the scale factor? The scale factor is just any of those numbers that correspond. You could choose any of these fractions, but what you always want to do is select ones that have values. Sometimes they don't have values. So if I do A, B, I'm going to write the 7 first, divided by, and then X, Y, X, this one right here, 14. And remember, you always want to simplify that fraction. Is 1/2 is the scale factor. So for similar figures, all the angles are congruent. All of the angles are congruent. And the sides are proportional. Okay. Are the polygons similar? So we're going to check that. We're going to check this in the section. Remember, all the sides, all the angles have to be equal to one another. So know that the angle A corresponds with the angle G. It is congruent to angle G. They're equal. We also have C. Angle C is congruent to angle F. And remember that last part, that last angle. We know 2 of the measures, so that means that the last one has to be what's left. So since we know these 2 are equal, this is where I gave you the example of 30 and 60. That means that this has to be 90 for both of them, making them equal. So I'm going to write angle B is congruent to angle H. We can write yes, that all of the angles are congruent. So all the sides are proportional. I'm going to go over it again just to make sure that you're okay, that you understand, because it really does matter. So for the sides being proportional, what we had to do was see the sides that would correspond. And we went through AC that corresponded with GAF. How did we know that these are the two sides that correspond? One marking, two markings. One marking, two markings. So we know that this side between those two given angles were the ones that correspond with one another. So that's the one I'm going to use for the scale factor. We don't need it, but this is why I'm showing you the scale factor. I'm going to do this one first, because this was written first. 9 divided by, and then this one, 6. You always want to simplify that fraction. So 9 divided by 6. You want to make it into a fraction. 3/2. So what happens when sides are proportional, all the sides have the same scale factor. If one of those sides, just one, does not have the scale factor, then these polygons are not similar. Just one. If one fails, the whole thing's messed up. Okay, so then the statement. I told you that the order of the letters matters. We're going to have the triangle A, and I'm going to write the similar statement, triangle G, because those two are the angles that correspond. And then I'm going to write B, and that corresponds with H. Then I'm going to write C, so I can have triangle ABC is similar to triangle GHF. All right, let's take a look inside. So we got to check first, are all the angles congruent? We have to remember a few rules. These are parallel lines cut by a transversal. So that means that these two are equal to 180. That gives you 180 minus 75 gives you 105. That means this one right here is 105. So they're consecutive interior angles. So if you add these two together, they have to equal 180. Okay, why does that matter? Well, look at this one. We have the two parallel lines cut by transversal, consecutive interior. Means that these two have to equal 180. That would be 180 minus 105 for this one. What does that give you? 75. We know that these two sides are equal. That means that it is either a parallelogram, which that's what it looks like, but we're not specifically told, or it's an isosceles trapezoid, because one pair of them is equal. Well, why does that matter? Because of whether it's an isosceles trapezoid or a parallelogram, it should tell us the angle measure that's left. This looks like a parallelogram, so I'm going to say that it is, that means opposite angles are equal. We really should have been told. Let's say that it wasn't. If it wasn't and it's a trapezoid, then the angles would just be switched from the ones that we have. But that would mean that this rule would apply the same way. Alright, so let's call it a parallelogram. Opposite sides are congruent. Opposite angles, are congruent. And then this one also makes it a 75. So I have 105, 75, 105, 75. So are all the angles congruent? Yes. Since I don't have labels, I'm not going to go through the motions of saying which one corresponds with which. We just got a yes, that they're all equal. Are the sides proportional? So this is something that we got to check. Since we're given this one first, that's what I would write first. So that's 4. And then it looks like the longer side. So we're going to correspond it with the longer side. Then we got to see, is that equal? So I'm going to put a little box with a question mark. Is that equal? Is that proportional to the shorter sides? So since I'm given this one first, 3. And this one's the shorter on this one, 2. You got to simplify those fractions, right? That means that implies 2/3. Is that equal? Is that equal to 3/2? No. So the answer to this one, are the sides proportional? That's a no. That means this is not similar. Once they are not similar, you cannot write a scale factor. You also can't write a similarity statement. What does that mean? What's a similarity statement? A similarity statement is this, where you're telling me which angles correspond with which angles on the other figure and which sides correspond with the other side. So since they're not similar, you can't write that. Alright. On the next one. Look, this one does label them all, but they also have the same markings, so we can tell that, yes, all of the angles are congruent. Are the sides proportional? We don't know the measurement, but look, we got 1 hash mark 2, 1 hash mark 2, 1 hash mark 2, 1 hash mark 2. That means that whatever value it has, it's going to have the same proportion. I'm just going to make one up, just so you can understand. Let's call this 5, and let's call this 2. So if this is 5/2, so is this one, so is this one, so is this one. And so you actually don't need the value, but you would know that they're the same. So this one's a yes. Because all the angles are congruent and the sides are proportional, then you can write a similarity statement. On this one, it's fantastic. It doesn't really matter where you start. So we're going to say A, B, C, D, E is similar to, and we always should try to go in alphabetical order, especially when it doesn't matter where you start. So we're going to go V, W, X, Y, Z. Okay. Scale factor. Determine the scale factor. On these, you always have to be told that they're similar, or you have to solve that they're similar. And this one is assuming that it is. It's going to tell you these are similar. So now we just have to see which part corresponds with what. On this one, it's kind of easier than you think. Look at this. This is the biggest side right here. So it has to correspond with the biggest side right here. This is the smallest side. That means it has to correspond with the smallest side over here. Why does that help? That means that the triangle ABC is similar to the triangle, and since I said AB, that's the middle side, so I have to do, and then I'm going to go to the smaller side, so I'm going to have to start here, G, H, because that's the middle side, and then I'm going to go to the smaller side, F. I'm going to say it again, how I figured this out. So I just wrote the letters how I wanted them in order here. So A, B, C is what I chose. You can choose a different order as long as the second one still corresponds. So A to B is the middle one. And when I looked at it, it was hard for me to know if I was going to go GH or HG. How did I know which direction to go? Well, it was because of that second side that I had to know I was going to go this way. That means that this one was the way I had to start. G, H, F, and helps me with the middle term. A, B, the middle side, and then the smaller side. B, C. We did that. Most of the time that is given, because then we could say that AB is the side that's going to be compared to GH. Or, like I mentioned before, the middle side with the middle side. That would be 7.5 divided by 5. Because that's the middle side with the middle side. We already had done this at the top. Always simplify your fractions. 3/2 is the scale factor. On your homework assignment, please write scale factor. And this is what I'm looking for when it says similarity statement. Let's take a look on the side. Okay, so this one gives us the values, and we want to say since A, B, C, D is similar, and now we got to see which ones correspond. We started with the 105, that's Y. And then we did B, which is the 85, so that would be X. Then C was the 100, so that's W on this figure. And then the one without a value was G, making Z the one without the W. On this one, just like in the page in front, what I said was the smaller side with the smaller side, the big side with the big side. So the scale factor. You could go, all right, this one's the biggest, and so is this one. Or the middle term with the middle term. That's what I meant to say. Let's see if they correspond. What the scale factor is. Since this one's written first, we want to write this first. 7. And then 14. Giving you the scale factor of 1/2. Please don't write this down. I don't need you to write it down. But let's say that you chose another side. Let's say that you chose this one. Well, both of the opposite sides on this are the same, and then both of these are the same. Let's make a different notation for this. So we still have 5 and 10. We always want to reduce that fraction. 1/2 is still the same scale factor. So the cool thing about this is that if you're told that they are similar, it should always have the same scale factor. Otherwise, you did something wrong. All right, so we have that A, B, C, D is similar, And then I told you that since the angles were the same and it didn't really matter where we started because of the values, then we try to write it in alphabetical order. V, W, X, Y, Z. The only numbers that we have are 4. That means all the sides are 4. And then 3. That means all the sides are 3. This one's the one we wrote down first in our similarity statement. So that's the one that goes in the numerator. 4 divided by 3. Make sure you always simplify your fraction. It's still 4/3. And then our last section. Find x with similar polygons. So here we have the triangle ABC corresponds with, so it says A, so that has to be G because of the markings of the angles. C corresponds with F. That means that B corresponds with H. Oh, sorry. These are similar. So we're using that fact to solve for x. And the reason that we did this section before is because of this. Well, if we know that this is 12 right here, the AC part, that means that that's going to correspond with the GF part. We can also know that the other ratio is going to be equal to this one because it's proportional. I have to use FH. And the reason that I have to use it is because that's the X and that's the value I'm looking for. Since it's the second one that I wrote, it has to go on the bottom. Which one does that correspond with? Since I use the last 2 letters on this one, it would be the last 2 letters on this one, BC, which is 9. From here, we're doing the same thing we did in the last section. 5 times 9 is 54. And that's equal to 12x, because we had to cross multiply. Divide by 12 to both sides. I have a 4.5. That's how I'm going to leave it for today. Alright, so let me say it again. You really could have used any other side. So you could have used AB. As long as you use the values with the x because you're solving for x. Let's take a look at the one inside. It's going to want you to solve for the x. And it's going to want you to solve for the y. Here, they did us a favor and they have the markings exactly the same. That means that 7 is the one that corresponds with the x minus 1. I asked you if the first figure's first, then that's what you write down first, then x minus 1. The second part, so this one corresponds with this one, is values that you have. You don't want to use the other variable. You're going to set up something that you don't know how to solve. So you want to use numbers for both of them. What do I mean? Well, take a look at this. If I use those 2 sides, I know that I'll have a ratio, and it makes it easy for me to solve. This one goes first because it's one drawn first, and then the denominator is the one that's drawn second. If you would have used these 2, it would just make it hard for you to solve, and that's why you don't want to do that. Okay, cross multiplying, we have 7 times 6. 42 is equal to 4. Remember, this has open parentheses because this is x minus 1. That means that whole thing needs to be multiplied by that 4. 42 is equal to, and then you have to do the distributive property. 4 times x is 4x. 4 times negative 1 is a negative 4. We draw the line. I'm going to add 4 to both sides. And 46 is equal to 4x. And then I divide by 4. And I have 11.5 is equal to x. Since these are links, those decimals and approximations are okay. All right, the next one. I want to solve for the y, so I have to use it. That means I have to use this 8. It's a numerator because it goes first, and then the 3y plus 3 is second because it's the second figure that you have drawn. So first and second is equal to. You could use these two numbers, and it'll give you the same answer, but I think these are easier. So you could say 4 divided by 6. They're going to be proportional. All of them are going to have the same ratio. So you could use the same one for both of these questions. Okay, we got to cross multiply. We have 4, open parentheses, 3y plus 3 is equal to, and then 8 times 6 is 48. Now we got to do the distributive property. 4 times 3 is 12y. 4 times 3 is plus 12 is equal to 48. We're going to draw the line, subtract 12 from both sides. 12y is equal to, and then we got 48 minus 12, 36. Divided by 12, y is equal to 3. So like I keep telling you, you just compare the two sides that they correspond, and make sure you set it one up that's easier.